Hello, everybody. Uh, should I start? Welcome, everyone. First of all, I wasn't expecting such a crowd. It's like very crowded. I was expecting like a smaller meetup, so I feel very excited about it. And sorry about that. First of all, let me introduce myself. My name is Fatih Erikli. I am originally from Turkey, but I work and live in Poland, Krakow. So this is my GitHub account, fatihirikli.github.io. I have some projects related with machine learning and like text processing. So first of all, I will start to define. Defining the words or like noun phrases for my presentation. The first thing is like I will try to define what is text processing. So text processing, we can like try to generalize them by in like three levels. The first thing is creation. So creation means like you have a computer, you have a data structure and you want to create a natural language from that data, that structured data, and like this is an example of creation. This is like pretty much the same that what we are doing with like strings or like text processing in like daily basis. Nothing special in that case. Or auto-generated emails can be an example of creation task. And the manipulation is a little bit harder than first level. Manipulation can be like spell checkers can be an example of manipulation or text formatters. And the first step is like today I will be talking about that step, interpretation. Natural language understanding is one of them. So like we have a natural language. For instance, we have a message or we have an email or we have a news item, and we want to interpret that, or for instance, we want to understand that, like in the computer level. What is it about, or how can we respond to that text, etc. And second task is sentiment analysis. Probably you heard about it. For instance, like you have a news item or something in your web page, and there are some review sections or comments, and you want to know is this review is positive or negative. This can be an example of sentiment analysis. And the fourth one is document classification. It's pretty much the same as sentiment analysis actually. In document classification, you have a document which is unlabeled and you are trying to label them by machine learning or by your algorithm. Also spam checking can be an example of document classification. So this email is spam or not is a classification problem. So machine learning. In the first slide, I try to define what is text processing, and I want to define what is machine learning right now. So starting more than half a century ago, scientists became very serious about addressing the question that can we build a model that learns from available data and like makes some decisions or predictions about it. So this is actually this is very different than how we program the computers. It's very changed the direction of programming actually. So machine learning is the science of getting computers to learn how to perform. And I will share the presentation, by the way, and you can follow that article to learn more about the definition. By the way, feel free to ask question. Feel free to interrupt me to ask a question. So, and like I defined what is text processing and machine learning, and now I want to define what is artificial intelligence. So first, the artificial intelligence is intelligence by demonstrated by machines. And machine learning is an application of artificial intelligence. So artificial intelligence is broader concept of machine learning, or machine learning is application of artificial intelligence. So we don't actually, there are some other ways to achieve artificial intelligence, like different than computers or machine learning. And artificial intelligence will not kill us unless we want them to. Probably you heard a lot of rumors or like science fictional thing, like news about it, like the artificial intelligence will take over the world and uh, they they will take our jobs and we will like they will take over the world, etc. But I believe it's far away from the reality. So the science fiction is far away from the reality. Artificial intelligence is still controlled by us, and like it's not harmful. So what is the difference between traditional approach and machine learning? So in traditional approach, for instance, we have a simple Python program. Like we created a file, hello.py, and simply we put print hello world, and we are doing some mathematical math expressions inside. So what we have here, we have a data from the user or from the text file or from somewhere. We have a data input, and we have a program that our Python file, Python script. And we have a machine, we have our computer or server, doesn't matter, and we have output. This is our traditional way to program something. That can be a web page or web application or mobile application, doesn't matter. And we have a new or different way to develop something or solve a task, and it's machine learning. In machine learning, the steps or the flow is different than the first step, and actually it's really changing the way to develop something. So in second section, we have data in that here, and we have output. Like as you can notice, in the first approach, we have data, and the output is coming after the machine process. But now we have data and we have output. So the output is trained data or predefined or pre-computed data, and data are input. And we have a machine. So in that approach, we are giving the input, we are first giving the output, so the predefined values, and letting machine to learn how to compute by looking at the relationships between the input and output by some probabilistic methods. And like at the end, we are having a program defined or compiled program that can compute any function or task without explicitly giving some set of rules. So this is an example application, spam or not spam. So we have some emails and we don't know which. Let's imagine we are Gmail. You know, like we need to filter somehow the spam emails and not spam emails. So we have some emails and they are not filtered yet, and we need to label them, classify them. And we have an algorithm, let's say machine. And algorithm says this is not spam, so it can go to the inbox. And the second option is spam, so it shouldn't be visible in inbox. So how do they learn? First, we need some training data to teach to machine how to like learn how to classify. So we are labeling the emails first. Hey, this is not spam. This is spam, or these emails should be labeled as spam, and this is called training data. And we are giving that to the program actually. And after that after that training data, after that teaching process, machine gives us some values. It says, for instance, we received an email, and machine, we have an algorithm. It says it's 80% not spam or 20% spam. So in that case, this is not spam. So as you can notice, we have a percentage. So in machine learning, the results cannot be 100 accurate. So this is very important. In traditional way of programming, we have always some exact result. If we have an input, we have some set of rules. Like the result eventually will be the same for the same input. But in machine learning, it's different. So we need to make a decision. So for instance, we will have some tolerance. For instance, if we could have like 51% not spam and 49% spam, like it could be hard to define if it's spam or not spam. And we should develop our program to handle that case as well. It should be false positive, for instance. So this is the difference between traditional way of programming and machine learning to solve a problem. And in machine learning, results cannot be 100% accurate. This is the difference. And like we need to develop our machine learning. We need to develop our apps like by paying attention to that fact. So it should be fault tolerance. And that's an example training training set. In Internet Movie Database Review, so IMDb, probably you know about that website, like like it has a lot of reviews and like comments about movies, and it's Internet Movie database. So this is an example of training data. We have two folders: negative, neg, and positive. So this screenshot shows the positive one right now. And as you can see, we have a lot of defined reviews, and they are called like training data. Also, we have some negative reviews, and we have test data. It's a different folder. So tools in Python to do some text processing or machine learning. First of all, NLTK is the major tool to deal with natural language processing problems. This is like the most popular library or toolkit in Python. And the second one is TextBlob. TextBlob is like simplified version of NLTK. Sorry. Like I'm not a data scientist, for instance. Like I'm just a programmer. I'm usually developing some web applications. So for my case, TextBlob is TextBlob is more useful for me. Because in NLTK is like you have to deal with very low-level algorithms. TextBlob is a simplified version of NLTK. And Jupyter Notebook, Jupyter is a web application that allows you to create and share documents that can contain some graphs, equations, or visualization, or narrative text. So it's like not that different. It's not different than classical Python idle or Python interpreter, but you have your Python interpreter on your web browser. So it's a very useful tool to try text processing libraries. And I will show some examples from with that tool. So that's how NLTK looks like. So when you install NLTK in Python, it's not like you loaded whole library or whole package. After downloading NLTK, you should also need to install some additional dictionaries or packages to develop an application. For instance, you can get city database, as you can see here, or parser for, or like some tagger for Russian language, etc. So the NLTK has a huge library of dictionaries and predefined data and data sets. And like it allows you to download that data sets in your computer. And this is an example of Jupyter notebook. So this is a web application. So you open it in your browser and you choose your Python interpreter, Python 2 or Python 3, for instance, and you give your Python code, for instance, words. I have a list of 2 items, dog and jumps, and the second line you have an expression, and at the third line you get the evaluation, you get the result of that evaluation, expression. So now I will be talking about the text blob framework. So text blob, as I mentioned about it before, it's a high-level implementation or high-level helper of NLTK library. So the first of the thing that text blob solves is tokenization. What does tokenization means? Like converting text or words to, converting a text data to smaller pieces, for instance, to sentences or to words, because we need to split a text into some pieces to make some competition on it. And it has some built-in classification algorithms inside, and it also allows you to do some sentiment analysis. It has integration with Google Translate. This is a very cool feature, actually. You have a user comment, for instance, and you want to translate them into different languages, and it allows you to translate these text data to different languages. And also access to NLTK dictionaries and other algorithms. Also integration with WordNet. WordNet database. I will be talking about WordNet later. So how the text blob API looks like. First of all, we install, I didn't mention about the installation process of text blob because it's pretty simple. If you are familiar with Python, it's just pip install text blob and you got the library. First, you import text blob in a text blob class, and you give a text. That's it, actually. Then you can interact with text blob. And for instance, here, after the instantiation of a text blob, I have access to attributes of text blob library. For instance, when I call blob.words, it gives me a word list instance that contains all the words in the text. Also, I have a sentences in that case. So sentences, it gives me a sentence list. It's basically the text splitted by dots, but it's more than that, actually. For instance, if you have 3 dots, you have an exclamation mark, for instance. It also allows, it also understands that this is a different sentence. So we look at the words and sentences. As you can see, like you can get a word. So the words attribute is just a simple Python list. Also, like we have some methods of words as well. For instance, when I get blob.words for free, it is the describes. And when I get, when I call a method lemmatitize and call it with v is something comes from the wordnet. I'll be talking about it later. For instance, it gets the root of that word. So when you are dealing with text processing, you need to trim some things. You need to trim some parts of the word or sentence. So you need to clean your data. And this is a nice way to clean your data. So describes comes describe. Because like otherwise it should be two different words. Describes and describe are two different words, because like the computer doesn't know what does describe mean. Also it has like some implemented algorithms inside, for instance like spelling correction. As you can see, I have a bad spell sentence. I have good spelling, and like I'm just calling a correct method, and it gives me it makes some spell checking for me, and it gives the corrected result of it. I have a good spelling, and it's like corrected version of the first sentence. Also, you can get that in Word instance as well. I'm giving a word, and good, for instance, is a bad spelled word. So the spell checking algorithm gives me the corrected version and the some value that this is 100% correct or not. Sentiment analysis, as I mentioned about it at the beginning of the presentation, is like related with a text, related with the negativity or positivity of text. So it's called polarity or subjectivity in sentiment analysis context. So I have text, for instance, like Poland is a beautiful country. So the sentiment is, this is something positive, right? I love Poland. This is not the negative comment. And it gives us the polarity is like, if it's greater than 0.5, it means, in most of the cases it means something positive. So this is a positive comment because the polarity is 0.85 and subjectivity is 1. So what does subjectivity mean? The subjectivity means is this text personal, based on personal opinion or not? So for instance, like Poland is a country located in Europe. It doesn't have any negativity or positivity. It's just a statement. So in that case, subjectivity should be 0. Also, the polarity should be 0. And the third example is the worst restaurant I have ever seen. The sentiment, the polarity of sentiment should be -1 in that case, and subjectivity is 1. So the polarity is between -1 and 1. So the 0 polarity is like it's not polarized. It means that it's not, it doesn't have any polarity. And translation, this is the coolest feature, like I guess. Actually, it's not that hard to deal with Google Translation API, but it's I think it's nice to have an option to translate your text data to like with translate your text data in a like very simple way. So I have a command, Poland is a country located in Europe, and I want to translate it to Polish. So in that case, like command is a text blob instance, and text blob instance has a translate method, and I'm translating it to PL, and it returns me a translated version of that text. So I cannot pronounce that. I don't know Polish yet, but so this is a Polish Polish version of my command. Also, the instances have a detect language method. It gives you the detected language option. Also, you can translate that translated text to another language. For instance, like I translated my command to Polish first, and I translated it to Turkish. So building a classifier, if we get deeper in the classification, so text classification is the process of assigning tags or categories to text according to its content. So, for instance, if I want to give an example, for instance, like the categorization of news items, or as you can see in that example, or also spam classification, is it spam or ham? Like also what can be as sentiment analysis also can be a text classification problem. So we have some raw texts which is not labeled, and we have a process that we have a classification process that like labels them. For instance, like I have a text and it's labeled by as tag, sports, or art. So first of all, we need to have a training data. In like real world, you usually have like a very big amount of training data, but for the demonstration purposes, I just created a very simple training set. I have some titles or news items. Let's say titles or arguments. For instance, time is not linear. Time is not linear argument should be labeled as science. Like I want to have a classifier works in that way. For instance, like there is no such thing as AI. It should be labeled under science. Or Picasso was a brilliant artist. It should be labeled under art. Or like C++ is better than Java for programming personal computer applications, should be programming. So this is our training data. And we have a test case at the very bottom. So time is relative, should be science. Cubism is an avant-garde movement, art. Or Python is created by Guido van Rossum, should be programming. So like naive bias classification is the simplest algorithm to deal with text classification. It's a probabilistic classifier inspired by Bayes theorem. So probably it looks scary, the math formula, but it's not that it's not that hard when you get deeper. So naive Bayes classification works like you have a big table, cross table, and you have some labels. For instance, long, not long, sweet, not sweet, yellow. These items are the data, and we have some types. Actually, we have some types like label, banana, orange, or other. So we are trying to understand if this is a banana or orange. And we have some features. What is that feature? For instance, longness, or not long, or sweet. If it's sweet, it should be banana, for instance. We have that kind of values, and we are summarizing all the features and getting a total value for the banana. And for the given text, given example, the probability score is 500, and for the orange is 300, and the other is 200. So total 1000. So probably the given set is banana. The given image or text is related with banana. So that's how naive Bayes classification works, basically. So how to implement them? Like TextBlob has an implementation for naive Bayes. Like I would like to make an implementation, or like show an implementation of it in here, but I think it doesn't make any sense because it's just like robust implementation of the algorithm. So naive Bayes has an implemented structure in the library. So first, we had a training set like that. So time is not linear, or there is no such thing as AI. We are giving that training set to naive Bayes classifier, comes from the TextBlob library, and we are calling a classify method. It's very simple actually. Like there's nothing complicated in that case. The complication is behind the classifier. So when I say when I ask for the classification for text, time is relative, it gives me signs, because like time is time and relative most likely labeled as signs in the training set. And when I try to classify Picasso as a painter, it says me art. Also, like the TextBlob has prop classify method, it gives you the predicted possibility. So sorry, it gives you the possibility of an assignment. For instance, like this the sentence is related with art with that percentage of possibility. So 0.7 with 0.7 possibility, this sentence is related with art. So how does it work? Like we said, like I said, we need to have some features in. We need to have some features to like compete with Bayes classification. So features are the basic primitives of classification process. Like most of the classifier use something like if this word is included in that training set or not. And it gives us some possibility. For instance, like Picasso, if the sentence is if the sentence contains Picasso, probably it should be related with art. Like this is a feature that this is called feature engineering actually. So in feature engineering, we need to find a way to distinguish between the classes. For instance, like we can say, instead of just checking if this word included in that text, for instance, we can also do some translation. We can try to translate the original sentence to some other language and use that data as a feature. So when I get the features in the classifier, for instance, like most informative features, for instance, like if it contains is, it's probably related with art, but this is something fuzzy. I need, for instance, like this is why we need feature engineering. Like the is the most the word is, like emissar, is the most frequent used word in English, and like we need to exclude that word from the classification process. That's how the feature engineering works. We need to clean our data, for instance. So yeah, to get more accurate result, we might want to take only first or last words of the document. That can be an example of feature engineering. So how do we do that? We have a text document and we are getting the tokens of it. We are just splitting by space, so we are getting the words of the sentence. And we are getting first and last word of it, and returning a dictionary, returning a data structure that will be taken into account by the classifier. So let's try that feature extractor. So we defined the feature extractor, and we give it to the classifier. And for instance, like Picasso is an artist, is probably related with art, but 0.9 is, if you remember, it was 0.7 at the very beginning. Now we remove is and words, and it's like more accurate right now. So of course, this is a very dumb implementation of like feature extractor. So we can find more clever ways to make a classification. So this is the WordNet. Is the another the WordNet. We can get some more accurate results by using WordNet. So WordNet is a lexical database. What is lexical database? Or what is lexical dictionary? Lexical dictionary means that you have a dictionary, something like Oxford Dictionary, for instance, but instead of having the definitions of in that dictionary, you are getting the relationships between the words. This is the difference. So instead of dealing with text data, you are getting more annotative properties about an object. So how does it work? So WordNet is a graph that each node is connected to each other, and the top entity is entity. So everything is connected to entity. For instance, like me and banana is somehow connected to each other, because like at the very top we have an entity. So I can measure the distance between me and banana, for instance. So lexical nodes can be useful for feature engineering, that you can like make an assumption that like this is like you can make an assumption that if a word related with fruits, for instance, and it also has something related with fruits, you can give a possibility that this is 100% should be labeled under that label. So that's how WordNet looks like. When I get the definition of Poland, it gives me a graph. First of all, it says Poland, Republic of Poland, or Polska, so the Polish version of Poland, and the longer form of Poland name. And it gives me some cities under Poland, for instance, Lodz, Krakow, or Warsaw. And it also has a branch to European country. So it goes to European country. Then after one jump, you are able to get other European countries, for instance, like Ireland or Slovakia or Balkans. So like that can be a nice point to get more sense or like meaning of sentence or label them in a more accurate way. So in text blob we have like text blob allows you to interact with that database. For instance, when I get Poland, synsets means like synsets means the word one word can have more than one meaning. For instance, like Turkey is a country, also Turkey is a bird. So this in Turkey, for the Turkey entity, we should get more than one synset. So when I'm getting the first synset of Poland and Hungary, and I'm measuring the similarity between Hungary and Poland, and it gives me 0.3. Also, like in second line, I'm getting the difference between Hungary and Japan, and it gives me 0.09 something, because like they are far. Like beside of that, they are not connected to each other as same as Poland and Hungary, because like Poland is European country, it has just one branch to European country node, and also Hungary branches off from European country node. So like I also have a proof of concept that maybe you would like to look at it after today or like after the presentation. I have implemented a text classification. I have implemented a text classification service. Actually, like I would like to show it here. I'm not sure if I can, but you can find it in that address. So this is a naive Bayes classification. So if you would like to go deeper in text classification, and if you would like to know more about Bayesian classification, you can look at my code. This subject is like actually it's very hard to discuss about it, because like it's there's an algorithm and the implementation is hard to follow. So I thought like a proof of concept would be helpful for that presentation. So, and you can use it for spam filters or web page classification or sentiment analysis. Also, I can try to show it here in my computer. So that's the service. There's two trained labels and just one classification. It's just the stats and 92 words. And these are the endpoints. You can use it from another application. So that works as a like classification as a service. And like there are some UI to test it. Let's try to train something first. We have two labels, science and tech. And I want to train something else. For instance, I will just give some nonsense words. And I will label them as Pykonik. Oops. Yes. And yeah, the text has been successfully fully trained. And let's see how the data is stored behind. So when I get science, I trained them in this morning before the presentation. In the science or recycling has 2 points, for instance, or tech, Uber has 7 points. If the if the text contains Uber, probably it's related with tech. So it can be an assumption. Also, let's try Pykonik. So all of them have 1 point. Let me train it again. I will train. I will extend my training set right here, right now actually. So let's try again, Pykonik. Yeah, as you can see, Python has 2 points and Pykonik has 2 points. So when we classify them, we are in Pykonik. So the prediction is Pykonik. So what if I say we are in Uber? It should be related with tech because like the biggest point is tech. So the source codes are available on GitHub. Like feel free to ask something or reach out me to like if you have any question. Actually, that's how the API of it works. So it has an HTTP REST API. I'm calling train endpoint, classify endpoint. For instance, colors should be related with art. So we already saw that. And some sources or like books about machine learning, I would strongly recommend you reading natureofcode.com. It has a very clear overall about like neural networks or machine learning. Also, I can share my presentation with you. It would be great to check the links, etc. That's it. And is there any question or? So I will repeat the question after. Hmm. Okay, so yeah, this is a very specific question. So I will repeat the question first, if I understand correctly. So the question is related with the size of training data should. Uh, okay, yeah, the training model itself, should we run them in runtime or should we persist them somehow? So like I don't have a specific solution for it, but like I was trying to solve that problem by using Redis. I was somehow like I was trying to persist them in Redis store. Also in that POC, I used Redis to store the model actually. But of course, like it's different in other machine learning problems. As like for instance, for image classification, you need to have something else. Maybe like I don't have a specific solution for now actually. Okay. Okay, so the question is, how do we rely on test data? So the like being sure about the test data is correct or not is like another branch of machine learning. So first you are also like you need to have a test data, not only training data. So you are having a model and you are testing your model by testing by like comparing with your test data. So like yeah, like it's like a process. It's already the process of developing something with machine learning because like there is no solution that you can just uh, work for every problems. So yeah, like if you look at, for instance, like Keras, this is a Python deep learning library, keras.io. You will see some like chapters about you will see some chapters about like being sure about training data or how to develop that training data or the model. Also in Keras you are compiling your model actually, and you are trying to improve your model. Also, you are using like some other computer resources, for instance, AWS, to compile them. Okay.